Right, number 10 then. The curve C has equation, so it's a cubic equation. Y equals x cubed plus 3x squared minus 9x minus 13. Part A says find the stationary points of C and determine the nature of each of these points. Okay, let's have a look at this one then. I've written out the question again. So we need to get dy dx first then, don't we? So here, dy dx then. Powers, so we just bring the power down, 3 lots of x to the 1 less than 3, which is 2, plus the 2 comes down to be with the 3 to make 6, x to the 1 less than 2, which is 1, minus x goes to 1, minus 9 lots of 1 is minus 9, the constant goes to 0. So we can just write that down here, 3x squared plus 6x minus 9, let that equal 0. There's a 3 common here, so we can write 3x squared plus 2x minus 3, isn't it? Equals 0. I've just taken a 3 out as a common factor. So that's equal to then 3, and we should be able to factorize this with little difficulty. Because we've got a 3, so that's got to be 3 and a 1. We've got a plus 2 here, so that would be plus, and this would be minus, wouldn't it? So straight away then we can see the turning points. Dy dx is 0 when this equals 0, or when x plus 3 equals 0. This one tells you that move the 1 across, you get x equals 1. And this one tells you move the 3 across to minus 3, and you get x equals minus 3. So here's our 2 turning points then. Now we have to find their nature, stationary points. So I'm going to get the coordinates. Stationary points, do we need the coordinates? Well, let's determine their nature first then, and then we'll get the y coordinate just to finish things off. So is it a max or min? So let's just differentiate again. Now, what have we got for the second derivative? Now differentiating dy dx then, d2y dx squared is equal to, 2 comes down to be with the 3 to make 6, lots of x to the 1 less than 2, which is 1, and then the x differentiates to 1, and there's 6 lots of 1, so I can just write it like so. Now when x is 1, put that in, and when x is minus 3, we'll see what we get. This one is positive, because 6 ones, that's 12. Minus 18 plus 6 is negative. So this one, because it's positive, it's a min. And this one, max. Okay, so the stationary points then occur at x equals 1 and minus 3. And we know whether they're positive or negative. So let's just get the y values to get the coordinate, just in case that's needed. So y is equal to then, put 1 in, it's easy enough to get. What's the equation originally? I've got it here now. It's x cubed plus 3x squared minus 9x minus 13, which equals 1 cubed plus 3 times 1 squared minus 9 times 1 minus 13. 1 plus 3 ones are 3, that's 4. Take away 9 is minus 5. Take away 13 is minus 18. And we'll do the other one now while we're at it. At x equals minus 3. The y equals, that's minus 3 cubed, which is minus 27. Minus 3 squared is 9. 3 nines are 27, so that's plus 27. Minus 9 times minus 3 is plus another 27. And then you've got minus 13 at the end. So these two cancel. 27 to 8, 13 is 14. So at 1 and minus 18, we have a min, don't we? At the minus 3, and value of 14, we have a max, don't we? That's what we said. Okay then, I think that's more than sufficient for this question then, all the information we've given there for the answer. Good.